next law? Well, this next one is basically the integral form of Coulomb's law. We call it potential energy. Potential energy is always related to a force by the following. E potential is, so in other words, forces are related to potential energies just by their gradient. We call it the derivative. And so if you know a force, you can get the potential energy just by integrating it. So in the case of Coulomb's law, we just have to integrate the force over r. Sorry, I should have kept my dimensional constant here the same. You get the idea. And we do this from infinity to r. We make it a definite integral. So we imagine we start with these charges at infinity and we bring them to an r and we integrate the force over that entire movement. And of course, force times distance, what units is that? Energy, right? That's work. So that's, everything works out. So when you do that, you plug in this into here and you integrate and you get something that looks very similar. Just be careful because it looks so similar you can misuse this. Looks pretty similar, except you notice there's just an r in there. So that's important. So when we look at diagrams of I guess the first one I have here, let's say Q1 equals minus Q2. So it's the opposite charge. And if I plot potential energy, with that being 0, I'm going to get something that's 1 over r that looks like that. You know. And the derivative at any point is opposite the force at that point. So this is a positive curve, positive slope, sorry. The opposite of that is negative, so that says that this force pulls these two charges together. So they want to go down this potential energy gradient. And likewise, if you do Q1